Hello, today we are going to look at a very interesting topic, which is about collisions of objects with each other. But actually, it can be not only collisions, but also situations like a body being blown apart due to some internal processes like the explosion of a grenade. After the internal energy of the fuel of the grenade is converted into the energy of motion of the fragments. And this situation we can also describe with the help of the laws of conservation of momentum and the law of conservation of, for example, energy. So, in this case, if we're talking specifically about collisions of some objects, we need to realize that these collisions are of different types. The kinds of collisions, and of course the two most common types of collisions, are elastic and inelastic collisions. These collisions will be described by their own laws, and somewhere these laws will work in both cases. Somewhere you have to take into account certain nuances. So let's take a close look at each of them. So the first type of collision we will consider is inelastic collision in this case. This type of collision says that when these objects interact with each other, after the collision they're moving in the same direction with some common velocity, so we can consider them moving together as one common body. Let's say we're looking at an example like this where we have two cars, one of which is moving with some initial velocity and the other car is standing still. These cars can have equal mass or different masses. It doesn't matter much, let's keep it simple. Let the masses of these cars be the same. Or then the question arises, during this type of collision, what will happen to this system? Obviously, the first carriage, once it hits the second carriage, will make the whole system move further in the same direction. But the velocity will be different. How to calculate this velocity? And that's where the law of conservation of momentum comes in. We understand what the system was before the collision and what it was after the collision. So in these cases, it's important to make two drawings and show in them these two states of the system. So now these two cars have some common velocity, which we have to calculate. Let's write down the total momentum that this system had before the collision. In this case, we can see that only the first object had momentum, and the second object had no momentum. Therefore, let's write it as 0. What did we get after the collision? The final momentum is the sum of the momenta of these bodies. In this case, we can consider these two cars as one common body because they are traveling at the same speed. So when we add up these masses, we get the travel of these masses by a certain speed that we've got at the end. Based on the law of conservation of momentum, we can say that the values of the given quantities will be equal to each other, and then we can equate the given parameters to each other. After the calculation, we get an expression for the value of the terminal velocity of this system. And we can see that it is half the initial velocity of the first object. It is obvious because at impact, a part of velocity will be naturally lost because the amount of motion of the object now spreads to a larger mass, and this process will slow down the motion of the system as a whole. So, thus we obtain that the momentum of this system is preserved here, and this allows us to calculate the value of the final velocity. In terms of energy, if we think about what the energy of this system as a whole is and whether it's conserved here, we have to compare the energy of the system at the beginning with the energy of the system at the end. This is very simple. Let's calculate the energy of the system at the beginning. We realize here that we're going to be calculating specifically kinetic energy because we're talking about the motion of these objects. And to do that, we need to calculate the energy of the motion of the first carriage because it was in motion at the beginning. What do we get at the end? we see that we have both cars moving now, so we calculate the total mass of this system. And we know the total velocity of the system. It's half the initial velocity. So we have to multiply by half of that velocity, square that, and then divide that by 2. Let's make some simplifications and calculations. Here we can reduce the 2. Respectively, we get, after the reduction, that we are left with the mass of one object, the square of the initial velocity, and divide that by 4. Comparing the final energy and the initial energy, we see that the final energy of the motion of these cars is half of the initial energy. Why did this happen? Well, it turns out that in this kind of collision, some of the energy of the object's motion will be converted into other forms of energy, like sound or heat, deformation, or some other kind of energy that will take over that part of the energy. So if we're talking about the energy of this process, the energy in this case is not a constant. This must be taken into account when we talk about inelastic collision. As for the elastic collision, on the one hand it is simple, on the other hand it can be a little bit more complicated. An elastic collision is characterized by the fact that the two bodies have different velocities after impact. For example, we might consider the motion of two billiard balls toward each other, that were traveling at velocities Vy and V2, and upon impact, they can fly in different directions, with velocities of something like V3 and V4. Oh, that is in this case already, in such course of collision, the bodies after impact have different velocities, not only in modulus but also in direction. And then the question arises how to describe such interaction. And here we can say that in the course of elastic collision we apply two laws at once. These are the law of conservation of momentum and the law of conservation of energy. So in this case, we can say that the total momentum of this system is constant, and the total energy of this system is also a constant. And having written these laws in the system, we can see that there are two equations for solving the problem with two unknowns. So we can conclude that for different kinds of collisions we can use the laws of conservation of momentum and energy, but depending on the type of impact, either both of these laws or one of them may work. This must be taken into account when solving such questions. So we're going to practice solving these problems, and we're going to look at specific examples to apply both of these situations. That's all for now. See you later. Goodbye.